Kafka uses shashed zero copy to achieve lightning-fast streaming by minimizing the overhead of transferring data between disk, memory, and network. Here's a breakdown of how it works. 1. The traditional data transfer process. In a typical data transfer operation, data is read from the disk into the kernel buffer, then copied from the kernel buffer to the application user space buffer. Finally, it is copied back from the user buffer to the kernel network buffer for transmission. This process involves multiple redundant data copies, consuming CPU and memory resources. 2. Kafka's zero-copy optimization. Kafka eliminates these redundant steps by leveraging the send file system call provided by the operating system. Here's how it works. 1. Reading data from disk. Kafka stores messages in log files on disk. When a consumer requests data, Kafka identifies the relevant log segments. 2. Using send file for direct transfer. Instead of copying data into user space, Kafka uses send file to transfer the data directly from the disk to the network socket. The OS kernel handles the entire process, reading the data from the disk and writing it to the network socket without involving the Kafka application. 3. Bypassing user space. Since the data transfer skips user space, there's no need for extra CPU cycles or memory allocations for buffering. 3. Benefits of zero copy in Kafka. 1. High throughput. By reducing CPU and memory usage, Kafka can process and deliver millions of messages per second efficiently. 2. Low latency. Data is streamed directly from disk to the consumer with minimal delays, making Kafka ideal for real-time applications. 3. Reduced resource usage. Zero copy frees up CPU and memory resources for other critical Kafka operations like message batching and offset management. 4. Efficient for large data transfers. Zero copy is particularly beneficial for transferring large files or streaming large volumes of data, as it avoids bottlenecks caused by traditional copy processes. Real-world application. Kafka's zero-copy optimization allows it to power high-throughput, low-latency systems, such as log aggregation, real-time analytics, and event-driven architectures. For instance, Kafka can efficiently stream logs for companies like LinkedIn, Netflix, and Uber, handling millions of messages per second without significant resource strain. Why it's lightning fast. By using zero copy, Kafka achieves a streamlined data path: disk, kernel buffer, network. No intermediate copies are needed, making Kafka one of the most efficient data streaming platforms in the world.